Yo, what's up guys, and welcome back to my channel, The World of Knowledge with Ishan. Today's topic is about Rutherford's atomic model. So let's get to it. Now, before we go to Rutherford's atomic model, we must understand what atom is. Atom, when first found, was practically known as indivisible and also was given the title of being the smallest particle of the universe. Now we know now that it's not the entire truth. Atom is divisible and consists of neutrons, protons and electrons. And there are also many things you know about atoms. So what is the most special thing about Rutherford's atomic model? What were its success and its failure, meaning defects? So let's go into it. When the electron, proton and neutron were discovered, Rutherford in 1910 wanted to discover a new thing. Obviously he wanted that physics Nobel Prize, so he got it. How? Well, he discovered nucleus. Well, there's a difference between neutrons and the nucleus. Now as I said, the word nucleus. Nucleus is a spherical type of thing located at the center of the atom itself. It has neutrons and protons in it. Electrons are revolving around it. And now to the Rutherford's atomic model. After the Rutherford in 1910 performed an experiment which consisted of a gold foil and a fluorescent screen which was surrounding it from all sides. Now note that this experiment was done in a vacuum. A vacuum is something that sucks all the air out and there's no other particles in it except the things which are placed inside it. So here we are. Now he then used a alpha particle emitter. As you can see on this diagram, which I didn't say before, he used a radioactive element of polonium or radium, both of them, or one of them. Now after these emissions, we can see it clearly that not all the rays are going in a straight direction. Some are deflected 180 degrees backwards or in different directions. You can see another picture that just popped out on the screen. Yes, that is the thing showing what happened when the alpha rays hit the nucleus. There are some deflections. Now, leaving the deflections aside, there's one more thing that we need to know. What is that? That is, not all were deflected. There were some undeflected particles which you can see come straight, go straight. So let's go to our second part of the topic. Three parts of this video. One was the experiment itself and the discovery of nucleus. The second was conclusions, and the last but not the least is the defects of this Rutherford's atomic model. Conclusions. The conclusions for Rutherford's atomic model, I am just going to say them in points. Now, point number one. All atoms contain a single heavily charged particle at the center, which we know as nucleus. Now, this heavily charged nucleus is positively charged, while the electrons around it is negatively charged. So point number two is actually the same which I said, but that the negative charge particle just revolves around the positively charged particle. Okay, we know that electrons revolve around nucleus. Point number three. The number of protons is equal to the number of electrons. Yes, this was also one of the biggest finds that any person would ever had. That is a very good thing for us. Thank you, Mr. Rutherford. So let's go to point number 4. Point number 4. The centripetal force is equal to the electrostatic force. Point number 5. Only a very small volume is occupied by the nucleus. Okay, that's a very interesting point over there. So by 5 points, we know that what was Rutherford's atomic model. Now there was a lot of there were actually 2 defects in Rutherford's atomic model, and I will just make them simple for you. Now going on to our last but not the least, but make sure you subscribe. I need subscribers right now. So defects of Rutherford's atomic models. Here we come. Now Rutherford here was using a classical electromagnetic theory. I'll tell it about later, it's very complicated. So according to that, the electrons should emit energy continuously, and they would slowly be falling into lower shells and ultimately fall into the nucleus, which would collapse the atomic structure. I think they got any of it. In short, that electron will just consume more energy and will draw itself towards the nucleus, and voila, the end of the whole atomic structure. But that doesn't actually happen, does it? Yes, that doesn't happen. So what does happen? Okay, we are talking about defects right now. So let's suppose this happens. The atomic structure collapses. But what about the line spectrum and continuous spectrum thing? Yes. Now Rutherford here just noticed that there was a continuous spectrum, not a line spectrum. And don't worry, I'll talk about continuous and line spectrum because it's a completely different topic. So we'll talk about it later. Don't worry, I will discuss everything. So this now the point number 2 that we have, as I said before, that continuous spectrum was observed, but actually line spectrum should be observed. And then we have another guy named Bohr to solve up the task, the defects. So let's keep all of it for later, and then thanks for watching my video. And if you haven't subscribed yet, do subscribe, like this video and share, because as you know, sharing is caring. Bye bye.